So the last thing I wanted to show you was how to compute the inverse of a matrix using the Adjugate formulation. That's also included in the determinant section. So of course we're going to set A equal to 2, minus 1, 0, minus 1, 2, 1, 0, 1, 2 again. And we have that A inverse is equal to 1 over the determinant of A times the adjugate of A. Now what is the adjugate of A? The adjugate of A is equal to the transpose of the cofactor matrix. And what is the cofactor matrix? Well, it's going to have these entries C11, C12, C13, C21, C22, C23, C31, C32, C33, and of course the transpose flips this entire matrix along the principal diagonal. But what are the cofactors, or the cofactors here? Well, Cij is equal to negative 1 to the I plus j times the determinant of the minor Aij. So this means that we need to compute the determinants of all the minors and then figure out the sign pattern. Well, the sign pattern for a 3 by 3 is going to look like this. I'm going to have plus, minus, plus, minus, plus, minus, plus, minus, plus. So it's basically this checkerboard pattern. And so as soon as I figure out those determinants, those individual determinants, I can just plug them in here. And then I can take the transpose, and then I divide by the determinant, which we've already computed. So let's go ahead and compute all of those minors. But notice that there are a lot of minors to compute. There are exactly 9 minors, and so 9 cofactors that I ultimately have to compute. So let's do it. So what's the determinant of A11? Well, I take out the first row in the first column, so this is the determinant of 2, 1, 1, 2. We've seen this before. It's exactly 2 times 2 minus 1 times 1, which is 3. The determinant of A12 is equal to, well, again, we can just look at our matrix. I'm going to erase the first row and the second column, so I have minus 1, 1, 0, 2. And what will that ultimately mean is, well, the determinant will be minus 1 times 2 plus 0 times 1, or minus 0 times 1 rather. And so I'm ultimately going to get a minus 2 there. How about determinant of A13? Well, that's going to be equal to negative 1, 1, 0, 2. So I have minus 1 times 1, which is minus 1, minus 0 times 2, ultimately gives me a minus 1. And I just keep playing this game. So now determinant of A21, well, now I delete the second row and the first column, so I have minus 1, 0, 1, 2. Ultimately that determinant is going to be negative 1 times 2, 1 times 0, which is minus 2. Determinant of A22 is equal to, I removed the first row and the first column, so the determinant is 2, 2, 0 of 2 times 2 minus 0 times 0, which is 4. And determinant of A23, well, A23, I removed the second row, third column, so I have 2 times 1 minus 0 times minus 1, so I get 2. Now determinant of A31, I remove the third row and the first column, so it's the upper right corner, so I have minus 1 times 1, which is minus 1, minus 2 times 0 is 0, so I have minus 1 there. And now I delete, sorry, I made this kind of too big, that should be a subscript, A32, I delete the third row and the second column, so I have 2, 1, minus 1, 0, so ultimately a 2. And finally, determinant of a 3, 3 will be 2 times 2 minus 1 times 1, which is ultimately 3. And what was my determinant originally? Right, what was my determinant originally? Well, remember that determinant of A was equal to 4. And so when I plug this into the formula, A inverse is equal to 1 over determinant of A, adjugate of A. I have 1 over 4. The adjugate is the transpose of the cofactors, and now I know what the cofactors are. The first cofactor is going to be 3. The second one is minus a negative 2 because of the sign pattern. The next one is plus a minus 1. The 2, 1 entry is going to be minus a negative 2. This will be 4. Then I have, again, a minus a positive 2. Then I have a minus 1 here. This has a positive sign in the checkerboard pattern. Then I have minus a positive 2 again, and then finally 3, checkerboard pattern. And then I take the transpose of this thing. Ultimately, that's equal to 3/4, 1/2, minus a 1/4, 1/2, 1, minus 1/2, minus a 1/4, minus a 1/2, 3/4 transposed.